Okay, Philips 2014 version of this bulb. There's been an update. They've changed the number of lumens from 830 to 880 on this A-shaped warm white bulb. As always, we'll assess the performance of the bulb and then turn it down to see what the differences are. So the dimmer test, obviously dimmer in the bulb, and the bulb's at a very low light level, and then as you increase it up, it of course gets very bright. More importantly, the low-end range of this bulb is quite excellent, actually. Even of all the bulbs I've measured that have dimmability, sometimes at the very low range they tend to either drop off a cliff or they just don't dim down very well. This one's performing very well. Let's talk about flicker. Just out of the frame is the bulb, and obviously it's shining upon a solar cell. And the solar cell, of course, will convert that light back to electricity. And if you look at the waveforms on an oscilloscope, you can get a sense as to the amount of flicker the bulb has. As with every Philips bulb, with one exception that I've torn down, there's just no perceptible flicker. So this is one thing that's been consistently superior in the Philips bulbs. Okay, power consumption. The packaging says 11 watts. You can see it drawing 11.2 down to 10. Good, honest packaging. Sometimes bulb makers seem to be a bit optimistic. A bulb is, of course, power factor corrected at just the bare minimum for Energy Star requirements of 0.9. Okay, light patterns. The old incandescents were pretty consistent from vendor to vendor. You put the bulbs into the socket and they all tend to look the same. LED bulbs, that's not true. Lots of variation out there. Some are really great emulations of incandescent light bulbs, and some are quite dreadful. No, the Philips line has been quite good. The original bulb was this one here, was great. The one I tore down in the fall 2013, if you want to look at that video, it's here, it's in pieces of course. And then the bulb here today. The way I determine these is I use a light meter and I just record the intensity of light coming out at 10-degree angles. It creates a polar graph, of course, and then I graph them all. And if you look close, there's actually three lines here. That's the three bulbs, and you can see within measurement accuracy, they're all the same. Great stuff. So that means this bulb, yet again, is following the tradition of the two bulbs that preceded it, and it has a good light pattern. Okay, looks like a good bulb. Low flicker, good light pattern, reasonable energy consumption for the amount of lumens. So let's tear it down. Okay, top's come off, obviously. Same construction as the previous bulb. It has a glass envelope with a protective plastic coating so it doesn't shatter too badly if it breaks, and of course a selective coating of whiteness to, I presume, to regulate appropriately. Unlike the one in the fall of 2013 I tore down, which had a remote phosphor, this one you can see the yellow phosphor has been placed directly on the LED dies. This is the old 2013. It had the remote phosphor, they call it, the yellow dome here, and then these light bulbs here, which I believe they call them royal blue. They produce a deep blue kind of ultraviolet light, and the dome goes on top. That's been simplified here, and now we just have the LEDs with the phosphor on top. Okay, let's keep going. Okay, going a bit further, there's obviously an outside shell. They've moved away from that plastic-coated metal just to powder-coated metal. That's a good cost savings. As you can see, of course, the emitter array bonded to a cap of some sort, and the electronics have been fully potted. That allows the heat to be evenly distributed around the electronics to avoid hot spots. That should help with life. And obviously a plastic retention cap of some sort. So we'll keep on going. Okay, just starting to peel off the epoxy. You can see they've wrapped the assembly in this yellow material. It's Kapton or polyamide tape. They must fill in the factory somehow, like a little funnel, and then put more setting around it, because I presume that the Kapton here is to keep the molding compound from running all over the place. So here's the AC-DC converter taken, of course, out of all of its encapsulation. AC input on the left, and then the output to the LEDs on the right. The board is different than the one that's in the one I tore down previously from the fall, but it's a similar topology. On the left here, fuse for safety reasons, of course. We have here an inductor and the capacitor. That's for preventing conducted emissions. These bulbs, of course, since they switch at a relatively high frequency, have the potential of interfering with radio communications, so that filter there is to prevent that. It is the 2-inductor design that we have seen before. And when it flips over, it's the Cirrus Logic family chip, the 1610001. I'll pop the data sheet up. Now this is actually the same controller that we saw the one previously. On this side here, of course, bridge rectifier, AC to DC in. These are 2 MOSFETs for each inductor for switching purposes. Other features. This board has been cut out with a slot for better isolation. Some nice touches on the stand-up resistors. They've put them in sleeves so that when they get soldered on, I presume that there's absolutely no chance they can short. Otherwise, it is similar to the topology of the previous bulb, but a few changes here and there. Nothing too remarkable. Alright, well, there's another teardown. Looks like they've made a change here to the emitter array and some minor changes to the circuit board. They've done a bit of cost reduction on the case here. Otherwise, a bulb that performs fairly similar to the one it preceded with a few extra lumens.